So today, last day we did the theorems based on similarity. Good evening, students. So last day we did the session based on similarity, and today we are going to do some examples and problems based on that theorems. The theorems, in short, the theorems where if we have two similar triangles and PQR for say, the altitudes AD, PS. So AD ratio PS will be equals to BC ratio QR. That's case in case of altitude. If AD is the with median, then exactly same thing follows. The median ratio is exactly same with the base ratio. And if AD and PS are the angle bisectors, again the ratios will be same, angle bisector ratio to the base ratio. So based on that, we are going to solve few sums today. So the first question which is given is, in the following figure, DE is parallel with BC. The length of AD, BD, AE and DE is already given. And we need to figure out the AC and BC. Okay. So first of all, we need to first think about what are the two triangles are there which are similar to each other. So DE is parallel with BC. So we can say for the triangle ABC, the large triangle ABC, and the smaller one ADE. For ADE and triangle ABC, we first can write angle A equals angle A. Both, this is a common angle. And angle ADE is equals angle ABC. Angle ADE equals angle ABC. So it means what? It means the triangles will be similar to each other. So we can write triangle ADE will be similar with the triangle ABC. By which rule? By SSS rule. So once these triangles are similar, we also can write that their corresponding sides will be in a ratio. So we can write AD by AB equals DE by BC equals AE by AC. These are the three things we can write, because if two triangles are similar, their corresponding sides will be proportional. So let's see which two ratios we should choose based on the given data. So AD given, AB given, BD given, and AE and DE given. So AD is given. I'm just taking AD by AB equals DE by BC. So AD length is given 2 centimeter and AB length is given they haven't given you directly the AB, but they have give you the addition. So AD is given 2 and DE is given 4. So overall, DB is given 2.5. Sorry, the DB is given 2.5. So it will become 4.5. And DE is given 4, and we need to figure out the BC. So let's simplify this. It will give me the value of BC. The BC will come 4 into 4.5 divided by 2. 4 into 4.5 divided by 2. So that means it will give me BC equals 9. It will give me BC equals 9 centimeter. Now, in the same way, we need to figure out the AC. So we can take the DE by BC equals AE by AC. DE by BC equals AE by AC. So we know the value of DE, which is 4, BC, which is 9, AE, which is given 3.2, and we need to figure out the AC. So AC will be 4, AC will be 3.2 times 9 divided by 4. So 0.8, the answer will come 7.2 centimeter. So hence, it's very important that you write the answer. Hence, BC is equals to 9 centimeter and AC equals 7.2 centimeter. So that will be the answer. We use the basic proportionality theorem or the similarity triangle in two similar triangles. The sides will be proportional to each other. That theorem we used here. We got the value of BC as 9 centimeter and we got the value of AC as 7.2 centimeter. Let's see one more question on that. It's given perimeter of two similar triangles 25 centimeter and 15 centimeter respectively. One side of the first triangle is 9 centimeter. Find the corresponding side of the second triangle. It's the perimeter ratios are given and one side of the first triangle is given 9 centimeter. We need to figure out the length of the other corresponding sides. Okay, so let's draw two triangles. They are not given equilateral triangles. We cannot use anything. We cannot deduct anything from the perimeter. So we have to use the similar triangle property. So this is say triangle ABC and say this is given 9 centimeter and the perimeter is given 25 centimeter. And say one more triangle is there, which is say DEF. We need to find out the corresponding side of the DEF. So I'm taking this is the corresponding side and I'm taking it as X centimeter and perimeter is given 15 centimeter. Now, as per question, it is given that the triangle ABC is similar with the triangle DEF. So this is the triangle, these two triangles are similar given. So as the triangles are similar, perimeter of the triangle ABC will be and the perimeter of DEF is equals to will be in a ratio to any one of the similar side. So I'm taking it as BC by EF. So perimeter ratio are given 25 over 15 is equals to 9 over X. So what will be the value of X? It will be 9 into 15 divided by 25. So that gives you 3, that gives you 5. Overall answer will come 27 divided by 5. So I don't want to go for any kind of division. I will multiply 2 with the numerator denominator. It gives me 54 divided by 10, which becomes much more simple division, which becomes much more simple division 5.4 centimeter. So the length of the side, corresponding side will be 5.4 centimeters. So this side will be 5.4 centimeter. That will be the answer for this particular question. Let's move on to the next one. So in this question, I need to figure out that which two triangle will be similar, first of all. So we need to figure out which two triangle should be chosen. I'm choosing the triangle ABC with the triangle ADC. So in between the triangles, I have to first prove the similarity and then move on. So in the triangle A, B, C and the triangle A, D, C. So in this two triangle, we first need to prove the similarity. So obviously the first thing we can write that angle BAC equals to angle ADC. The first thing we can write. The second thing we can write angle C is equals to angle C because both the triangles has that angle common. So now we can say the triangles are similar by AA property. Is similar with the triangle ADC. Now once these triangles are similar, we can use the proportionality theorem in them. So proportionality theorem says that CA, we need the CA, CB, CD. So CA by CB, CA by CB is equals to CD by CA. For the smaller triangle, for this triangle CA is corresponding side CB, this CB, and for this triangle CD is corresponding to the side CA in the large triangle. So if we cross multiply, I'm getting CA square equals CB times CD. CA square equals CB times CD. Here I should change the name of the triangles. It is not ADC, it should be DAC. DAC. And this also should be changed DAC. Now the question can be why I changed it, because the A angle is corresponded to D angle and C angle is equal with the C angle. So that's why the name should be changed. So this was one more question. This next question says the two right angle triangles are given. The triangle ABC and the triangle DBC are drawn at the same hypotenuse BC and on the same side of BC. If the AC and BD intersect at P, prove that AP into PC equals to BP into P. So these are the two right angle triangles given. So what we can do, we can go for the proof. We have to prove the two triangles are similar. So which two triangles will be similar? The similar triangles will be, let's take the triangle BAP and the triangle CDP. For the triangle BAP and the triangle CDP. BAP and CDP. So first of all, we need to prove these two triangles are similar. So the first thing I can write, angle A equals angle D. The second thing that we can write is angle BPA, angle BPA, that means this angle is equal with the angle CPD is equals to this angle, because these two are vertically opposite angle. So hence these two triangle will be similar to each other. BAP is similar with the triangle CDP. So as these two triangles are similar, we can use the similarity the similarity property that their corresponding sides will be proportional to each other. We can write that AP by DP equals BP by CP. Now if I cross multiply them, it became AP cross CP equals DP cross BP. So that's what I need to prove. So that's proved. So we just need to think that which two triangles should be taken to prove the similarity, which has this sides included. The choosing of the right triangle is the key thing to solve this type of problem. Next we have a theorem based on ratio of the areas of two similar triangles. So how the ratios of two similar triangles are related. The first theorem under this says the ratio of the areas of two similar triangles is equal to the ratio of the squares of their corresponding sides. And we can see it appears in the CBSE for so many times, especially in the segment of 2005 to 2009. So let's draw let's draw two triangles, and it's given the triangles are already similar. So let's try to draw two triangles, two similar triangles. The first triangle is ABC. Second triangle is say DEF. So these two triangles are given similar. Triangle ABC is similar with the triangle DEF. These two triangles are similar given. That's already given. What we need to prove? to prove will be that area of the first triangle A, B, C by area of the second triangle D, E, F will be equals to the square of their corresponding sides. So that means either AB square by DE square or AC square by DF square, or it will be BC square by EF square. So this is what I need to prove, that the area of the triangle will be equal with the squares of the corresponding sides, ratio of the corresponding square of the corresponding sides. So we are going to draw something. We are going to draw two perpendiculars starting from A to BC. One is AL, another one is from D to EF, say ADM. So these are the two construction we have. Now, the proof. So in the proof portion, the triangles are similar already given, and we know the angle A, the corresponding angles are also equal. So we can write angle A equals angle D, angle B equals angle E, angle C equals angle F. These are the things we can write. Next, what we can do is we can write even the triangle, as the triangles are proportional, their sides will be in a same ratio. So we can write AB square, AB by DE equals BC by EF AC by DF. Now, let's find out the area of the triangle ABC. What will be the area of triangle ABC? It will be half into BC into AL. And what will be the area of the triangle DEF? It will be half into EF into DM. These will be the two areas. Now we should figure out their ratios. So area of the triangle ABC by area of the triangle DEF will be equals to half into BC into AL by half into EF into DM. Half get cancelled. So we are getting the ratio as BC by EF into AL by DM. So now if I can simply prove that AL by DM also means BC by EF, we can prove it. So last day we learned a theorem that if for two similar triangles, the altitude ratio will be similar with the base ratio. So using that two theorem, we can see that theorem we can write BC by EF is into BC by EF. So we can write it as BC by EF whole square. And as BC by EF is equals to AB by AB by DE, so it can be also written as AB square by DE square and AC square by DF square. So hence it is proved. That was the theorem based on the ratios of the areas of two similar triangles. So let's do the example type or application of this theorem. If the areas of two similar triangles in the ratio 25 is to 64, find the ratios of their corresponding side. It is given that the areas of two similar triangles in a ratio 25 is to 64, find the ratio of their corresponding side. So we are taking the triangle's name as the triangle ABC and the triangle say DEF. So let the triangles are triangle A, B, C and the triangle D, E, F. So in between these two triangles, the ratios of their areas given, and these two triangles are similar also. So it's given area of ABC of the triangle ABC by area of the triangle DEF is equals to, we can write it as AB square by DE square equals BC square by EF square equals AC square by DF square. So this ratio is given 25 by 64. This ratio is given as 25 by 64. So that is equals to, we can write it as AB square. So AB by DE whole square equals BC by EF whole square equals AC by DF whole square. These we can write. Okay. This 25 by 64 also can be written as 5 by 8 whole square. So basically what you can write as the ratio of their side, AB by DE will be equals to BC. If you do the square root of the entire ratio thing, BC by EF equals to AC by DF is equals to 5 by 8. So that will be the answer. That the ratio of the corresponding sides will be 5 by 8 using the area theorem on similar triangles. Let's do one more question. It's given the areas of the two similar triangles, triangle ABC and PQR are 25 centimeter square and 49 centimeter square. Respectively, if the QR equals to 9.8 centimeter, we need to figure out the BC. So these two triangles are similar and their areas are given. So obviously we can write the ratio of their areas will be in a proportion with the square of their sides. So we can write it as area of triangle, the first triangle ABC, by area of the second triangle PQR will be equals to the corresponding side. So BC is corresponding to QR. So BC square by QR square. BC square by QR square. So their areas are given 25 by 49 equals BC square by QR square. So if you do the square root both sides, it gives you BC by QR is equals to 5 by 7. BC by QR equals to 5 by 7. Obviously, whenever I'm doing the square root, I'm not considering any negative number because these are the lengths, they cannot be negative. Now, the QR is given 9.8. I need to figure out the BC. So BC equals 5 into QR by 7. So 5 into 9.8 by 7, which will give you 5 into, if I divide 9.8 by 7, it gives me, and if I then multiply it by 7, multiply it by 5, it gives me 98 by 7 into 10. So this get cancelled, it gives you 2. This get cancelled, it gives you 49. This and this get cancelled, it gives you 7. So answer will be 7 centimeter. The length of BC will be 7 centimeter. We use the area theorem to get the ratio of the corresponding sides, and then we just square rooted it. We got the length of the other side. This is one more question given, that the area of similar triangles are 81 centimeter square and 49 centimeter square. If the altitudes of the bigger triangle is 4.5 centimeter, find the corresponding altitude of the smaller triangle. So again, the same thing we need to do. We will draw two triangles, two similar triangles. So that's say ABC, and AL is the altitude, and that's say DEF, and say DM is the altitude. For altitude of the bigger triangle is given 4.5 centimeter, and I'm taking it as say X, the altitude of the smaller triangle, and I need to figure out the length of AL. As these two triangles are similar, their ratios will be equals to the square of their altitudes also. So area of triangle ABC by area of the triangle DEF is given AL square by DM square. So area of AB is given, ABC is given 81 over 49 equals AL square over DM square. Now we can write AL by D. Sorry, I did a mistake. That is, this portion will be in reciprocal form. So the larger triangle I have taken it as DEF. So that will become 81, and the smaller one will become 49. So AL by DM square, DM will be equals to 7 by 9. So I need to figure out the length of AL, which is X, and that will be equals to DM into 7 by 9. DM into 7 by 9. So what will be the length of X? It will be 4.5 into 7 by 9. So you just cancel it out. It gives you 0.5 times 7 gives you 3.7 centimeter. Okay, so length of AL, the altitude of the smaller triangle will be not 3.7, it will be 3.5. 3.5 centimeter. So that will be the answer. We used to have lot of questions based on this two theorem. I have just chosen the most important one or most common one. So this one is out of them. It's given in the figure, triangle ABC and the triangle DBC has the same base BC and AD. If AD intersect BC at O, prove that these two triangles, area ratio of these two triangles will be AO by DO. So let's try to draw this figure. It's given triangle ABC and DBC. So the triangles should be, this is the BC triangle, BC length actually. So this is the ABC and say this is the DBC. So this is the DBC. You join this two, this line become AO. Let me draw it properly. This is A and this is D. We joined AD, this is O. Now, we need to prove the area ratio is equals to AO and DO. So, we need the construction. In the construction, I will draw two perpendiculars, one from A, another from D. So this is the construction AL for say, and from D, I'm constructing one more perpendicular. So this constructions I have to do. This is L and this is AL and this is DM, two perpendiculars drawn on BC from A and D. Now we will try to prove the congruency between two small triangles ALO and DMO. Now the congruency is the similarity. So for triangle ALO and triangle DMO. So what we can say, the first thing that we can say is angle L is equals to angle M because both of them are right angle, so they will be equal. And the second thing that we can say, angle AOL is equals to angle DOM. These two will be equal Why they will be equal? Because they're the vertically opposite angle. So obviously these two triangles will be similar to each other. So we can write the triangle ALO is similar with the triangle DMO by AA rule. So once these triangles are similar, we can say AL by DM will be equals to AO by DO. We can say AL by DM equals to AO by DO by the proportionality rule for two similar triangles. Now let's write the area of the triangle ABC. So area of triangle ABC by area of triangle DBC is equals to for the first one the area will be half into AL into AL into BC by half into DM over BC. So half get cancel, BC get cancel. It gives you AL by DM, which is also equals to AO over DO, which I need to prove because we already got the ratio that AL by DM is nothing but equals to AO over DO. So hence we can write this ratio of the areas of the triangle will be equals to AO ratio DO. This is one more question given in which it says that D is a point on the side AB of the triangle ABC. So we have to draw the triangle ABC first. Triangle ABC, this is the triangle ABC. D is a point on the triangle ABC such that AD is to DB equals 3 is to 2. AD is to DB equals 3 is to 2 and DE is parallel with AC given. Okay, fine. Find the ratio of the areas of these two triangles. Triangle ABC with the triangle DBE. So first of all, we need to prove this smaller triangle and the larger triangle will be similar. So for the triangle ABC and ABC and the triangle DBE, DBE, we can write the first thing we can use that the angle B is equals angle B. These two angles will be common angle. This angle is a common angle. And as the lines are parallel, these two angles will be similar. You can either use that or you can use these two angles also will be similar because they are the corresponding angles. So angle BED equals angle BCA. Now, as I have written these two triangles already, I can say ABC is similar with the triangle DBE. The triangles will be similar. So once these two triangles are similar to each other, we can say the areas of the triangle ABC by the area of the triangle DBC DBE will be equals to AB square by the corresponding similar side DB square. AB square by DB square. Okay. The length of the AB and DB now I need to figure out. It's given AD is to DB is 3 is to 2. So if I take this is as 3x, this is as 2x, then entire AB will be 3x plus 2x. That gives you 5x. So it will be 5x the whole square divided by dB. So what will be dB? dB will be 2x. So that is 2x the whole square. So that gives you 25x square by 4x square. X square get cancelled. It is 25 by 4. So that will be the answer. That ratio of the areas of the triangle ABC and DBE will be 25 is to 4. So next, these are the everything about the areas ratios of two similar triangle. After that, we have the Pythagoras theorem. The Pythagoras theorem, we all know what is the statement of a Pythagoras theorem. The Pythagoras theorem says that if we have a right angle triangle, say the triangle is ABC, we need to prove the AB square plus BC square equals to AC square. The square of the hypotenuse is equals to sum of the square of the other two sides. So we need to prove AC square is equals to AB square plus BC square. So let's try to prove it. We know all of us know that it is the Pythagoras theorem, but we haven't ever proved it. So let's try to prove it, and I'm going to use the similarity to prove it. So I'm drawing a construction that BD is perpendicular to AC. I'm drawing a perpendicular BD to AC. This is a perpendicular drawn. Now we have two triangles, ADB and ABC. In these two triangle, I'm first trying to prove the similarity between them. So the triangles I have chosen, triangle A, D, B and triangle A, B, C. So it's very simple to prove the similarity between them because angle A is equals to angle A. This is a common angle and both the triangles has a right angle triangle. So angle D equals angle B. Here the angle B is right angle. Now as the triangles are equal, as the triangles are similar, we can write the triangles are similar given. So we can write AD by AB equals AB by AC. So obviously from here we are getting AD into AC is equals to AB square. AD into AC equals to AB square. Now we will try to apply the same thing for the other two triangle, that is BCD and the triangle ABC. So for BCD, for triangle BCD and triangle ABC, the angle C is equals angle C and angle D is equals angle B. So the triangles are similar. So triangle BCD is similar with the triangle ABC. As the triangles are similar, we can write now, as the triangles are similar, their respective sides will be in a ratio. So DC by BC is equals to BC by AC. So if I cross it, I'm getting BC square equals DC into AC. DC into AC. So these are the two things I'm going to add. If I add them, I am having DC AD into AC is equals AD into AC plus DC into AC is equals to AB square plus, now as I am taking AC common, so it becomes AD plus DC equals AB square plus BC square. So AD plus DC will become AC. So AC into AC is equals to AB square into BC square. So AC into AC become AC square is equals to AB square into BC square. So that's what the Pythagoras theorem is. Hence we can say the Pythagoras theorem is proved. So next day we'll start with the questions related to the Pythagoras theorem. Most of the questions, we can have two different kind of question. That is, one is based on the finding the length of the sides, and other one is based on the finding the length of the, relation between the sides. That type of problems will be much more important, and most of the cases we have a common question in the CBSE exam. So next day we will start with that. Thank you for joining the class.